இப்போ எக்ஸ்டர்னல் பார்ட்டிசிபென்ட்ஸ் வரலையா?
சார் கொஞ்சம் பேர் தான் சார் வந்திருக்காங்க. ஒரு 6 பேர் தான் வந்திருக்காங்க சார்.
சரி, எனவே நம்ம ஃபேக்கல்டி எல்லாம் வந்துட்டாங்கல்ல.
ஒரு 10 பேர் வந்திருக்காங்க சார்.
எக்ஸ்டர்னல் பார்ட்டிசிபென்ட்ஸ் பிஜிஸ் ஃபுல்லா இருக்காங்க. நம்ம ஃபேக்கல்டி என்னன்னு பாருங்க, யார் யூஸ் பண்ணிருக்காங்க, நம்ம ஊர்ல வரலன்னு.
பிஜிஸ் வந்துட்டாங்க சார்.
பிஜிஸ் வந்துட்டாங்க, ஃபேக்கல்டி எல்லாருமே வந்துட்டாங்களா? நம்ம ஃபேக்கல்டி
இல்ல சார், வராதவங்களுக்கு அந்த டிபார்ட்மெண்ட்ல ஃபோன் பண்ணி சொல்லியிருக்கேன் சார், ஜாயின் பண்ண சொல்லி.
ஸ்டார்ட் பண்ணிடுங்கப்பா. ஹலோ.
எஸ் சார், நான் ஸ்டார்ட் பண்றேன். Gopika, you are not here audible.
Hello, is it clear, sir?
Yeah, you can start.
Okay. So, good morning, everyone. To get to know, to discover, and then to publish is all about the destiny of a scientist. A warm good morning and hearty welcome to all the speakers and delegates present here for the program on behalf of Department of Pharmacology, PST College of Pharmacy. PST College of Pharmacy was started in the year 2001 under PST Sons and Charities Trust. The college offers B.Pharm, M.Pharm, PharmD, and PhD programs and has been ranked 64th position continuously for the last 5 years by NIRF, accredited by NAAC, and got B++ grade in the year 2021. Among the pharmacy colleges in India declared by Ministry of Human Resource and Development, Government of India. The Department of Pharmacology was established in the year 2008 and have received various funds from DBT, DST, ICMR, and other funding bodies. The department has well-equipped laboratories focusing on drug discovery, neuropharmacology, cancer biology, neuropathic pain, and diabetic research with in silico, in vitro, and in vivo facilities. The program refresher course on research project writing, bioethics, and scientific communication aims to enlighten the researchers on research project writing and tapping funds from various funding agencies. The program includes virtual presentations by various experts in research, industries, academics, and government institutions. The program is scheduled to conduct for 6 days with 2 sessions in each day. Today's session starts with the inauguration and introductory remarks by our beloved principal, professor and head of the department, Dr. M. Ramanathan sir, Department of Pharmacology, PST College of Pharmacy. I invite Dr. M. Ramanathan sir to start the session with inauguration and introductory remarks.
Good morning, dear participants and respected Professor S. Kabilan, our collaborator, and we have a very we have many success stories since 2007. So when we met in Annamalai, so the research proposals writing is one of the important aspects and tasks which is many people are aiming at, and the success again getting a funding is one of the difficult tasks. Why? Because everybody applying to the funding agencies, out of this only 8 to 10% is got been approved, or maximum 11 to 12% is got been approved depending upon the funds available. So if you want to compete among this 10 to 11% means you should have a very strong credentials in research, and also your institution should be having good credentials. And apart from this, the proposals is also should have a good credentials, or could have some translation value, applications value, or even it can give some meaningful data or useful data to the society. So these are the some of the aspects which has been most widely been reviewed by the experts when you submit it. It's a 4-tier process. First, when you submit at the DST or DBT or ICMR or CSIR, at the basic level they screen it, and then it will send to the experts for peer review. Then the third stage, it will come to the committee, PAC committee, or the experts committee of 20 members. And once it has been done, the final scrutinization will be happen at the 4th stage. So that means you have to go through these 4 stages to get your funding cleared from the finance at the last stage. So even sometimes, even if it go to the finance, it be stopped because of some queries or some clarity asked for the experts present in the finance. So finance is totally different. They look more into a non-technical aspects. So these are all our experience, what we they did for past 2 decades. So it's our responsibility to transfer this knowledge to the young minds. So that's the one we thought it. We'll have 1 session of refresher courses for our students. Because when we see pharma is always compete with the health sciences. So where we compete with medical, dental, even biology, they also compete with the health science people or basic life science people. They'll also compete with pharma. But when compared to others, pharma, our research background is very, less, because we are not exposed much to the research aspects in our curriculum. But if you take other sectors, there are more advanced techniques have been used, even if you take chemistry part. So though we study chemistry, but we depend mainly on organic chemistry synthesis people, where we could be able to get some meaningful compounds or good compounds for our testing purpose. So these are all some of the places where we thought where we can go for win-win situations. And we will look for a collaboration. So when we have a collaborative research, then the chance of getting funding is also much on higher side. So considering all these parameters, we framed for 5 days, and 6th day will be the evaluation pattern, and followed by feedback, and then certificate distribution. So final day will be mostly of evaluation. What we taught for the 5 days, it will be given as MCQ pattern. and the audience has to answer it and submit the forms back to us. And once it has been evaluated, then we'll give you the marks for that one. Then we'll give you the certificate as you complete your refresher course. And this refresher course has been accredited by around approved by Tamil Nadu Dr. M.G.R. Medical University with 30 credit hours. So that means it has this program. When you appear completely and get the certificate, it has a very valid certificate because it has been accredited by the M.G.R. University as a part of the academic program. So that's one of the plus for this refresher course. Now, apart from this, we have planned in a very meticulously so that anybody who is delivering the talk, they have some research experience, they got some fundings, and they got a lot of experience as senior faculty in the field of academic research. So initially we thought we'll also take some industry people, but later on we thought industry is more of what to say, different type of approach they used to have it. So we thought we'll have it mainly on academic researchers. So we covered the entire aspects, what is being needed for any research funding agencies or what they're looking for, right from preamble to introduction to methodology, conclusions, PA expertise, budgeting, UCSC certifications, and the necessity for collaborations, as well as the ethical aspects of the research, including human ethics, animal ethics, then copyright violations, conflict of interest, then even plagiarism. So everything we have made it a very compact way, which we have made it all the programs with the proper expertise, with their consultations. Also, we made a very clear, we interacted with them very in a meticulous way, stating that this is the one which we wanted for our faculty members, those who are attending this. And end of the day, if any of you are interested, you can submit your proposals. Maximum 2 or 3 will be taken into the final day afternoon session. So you can present your thesis, present your research proposals. The members will sit and evaluate and give their feedback. What is plus, what is negative, where you can fine tune it, your research proposals. But that has to be done well in advance so that we can accommodate your proposals in the presentation. So maximum 2 or 3. 2 is good enough. 3 we can think it of how we can manage it out. Okay. So this is the way how we have planned it. So for this event, I welcome all the delegates as well as the speakers. First, I welcome our great friend of mine, and as well as we are very closely associated with the research aspects, and you can see many of our publications with the Department of Chemistry. Dr. S. Kabilan, Doctor of Science, recently got it. So we are very much happy to welcome you, sir, for this refresher program on behalf of the PhD College of Pharmacy, Department of Pharmacology, students and staff members. I welcome you, sir, for this course, and he'll be delivering the keynote address. So what I thought is he is an apt person to deliver the keynote address because of his vast experience. Almost 35-40 years he worked in the field of chemistry, and he got a lot of patent, he got a lot of collaborations, he got a lot of good publications, as well as he got many fundings also. So then I thought he may be the best person to ignite your mind as a first speaker. So I welcome you, sir, for this program. I also welcome all other speakers, those who are going to deliver it in the next coming days. Dr. Badiveran from JSS and Dr. V. Ramamurthy, Head Department of Biomedical Engineering, Sri Ramakrishna College of Engineering, and Mr. Justine, Dr. Justine from Pharmacology Department of OT, JSS. Then Dr. Gunasekaran, he is an assistant professor of Department of Zoology, Bharat University, Coimbatore. He talks more about the ethical aspects. And Dr. Michael, again, associate professor, Department of Microbiology. They are all our collaborators. We have somewhere we link with our Institute of BHG College of Pharmacy. Dr. Rani, professor, Department of Biotechnology and PhD College of Technology, and myself will be talking about budgeting. And most important aspect is every funding when we complete it, the most first job is the submission of utilization certificate and statement of expenditure. This is one of the toughest tasks for every PI. So I requested our accounts officer, who is in charge of this, to talk because as a scientist, we are not very strong in accounts. We look only on the research aspects. But when you look into the accounts and what is expected from the government bodies is totally different. So I thought that has to be presented somewhere to the audience about the taking the utilization certificate as well as the statement of expenditure for the funds what we received. And report submission will be done by Dr. A. Nagarajan. Again, he is one of the collaborators who worked with us in CSAR funding and nanoscience funding. Now he is working in Karpam College of Pharmacy. Now, apart from this, I have taken the help of our colleagues also, Dr. Muthukrishnan, Dr. Karthik from my department. So they'll talking about animal ethic aspects. And Dr. Uma and Dr. Shyamala from Cognicy and Chemistry department, they talk about data integrity, plagiarism, and copyrights. Because currently the copyright violations, plagiarism is being taken to a much higher side. So people should know even a small copying of your own figures and submitting to others, it's also a copyright violation. So people should know, the science should know, the teachers should know that. So we thought we'll have it that into the talk. And also human ethical aspects for Dr. Shivakumar and Dr. Rama. They are all in our ethical committees. And Dr. V. Shankar will give about the overall presentations about the drafting and the overall view. And followed by, we've given assignments to work on your home. And that 2 assignments will be presented on by the delegates on Friday, on 11th of March. So this is a planned way. I request all of you should attend this event. It has been planned very meticulously to benefit you all. So try to attend it, and whoever is attending continuously will get the certificates. And those who are submitting their question and answer, they'll get the certificates. It's all mandatory. We are taking attendance every day, and they'll be given by the in charge of my faculty, Mr. Ram Praveen, Mr. Ebin, and Ms. Deepthi. So they have been given in charge of these aspects. So with these few words, I welcome you one and all for this 1 week refresher courses on research project writing, bioethics, and scientific communications in a virtual mode. So have a nice interactive sessions hereafter, and looking forward all your cooperations also. Thank you one and all. Over to MC.
Thank you, Ramanathan sir. Next, we shall invite Dr. S. Kabilan sir. Dr. S. Kabilan sir. Dr. S. Kabilan sir is currently working as professor in the Department of Chemistry, Annamalai University, Annamalai Nagar since July 1988. He has been awarded with the highest academic degree, DSc, in 2021, awarded by Annamalai University. He has won the Best Publication Award and the Best Researcher, and is a UGC BSR Faculty Fellow with 140 publications and has guided 27 PhD projects. He had completed various projects of ICMR, UGC, and DBT and DST. Dr. S. Kabilan has research collaborations with Schrodinger USA, IASST Guwahati, PST College of Pharmacy Coimbatore, and NEHU Shillong. He has received grants worth rupees 2.1 crores and DST purse worth rupees 33 crores. Let us welcome Dr. S. Kabilan sir to deliver the keynote address and research introduction for the program.
Thank you very much. So Dr. Ramanathan DSC and the PhD College of Medicine.
A little bit louder, sir. Little bit louder.
Can you hear me, sir?
Yes. Now it's fine, sir. Yeah.
Oh, very good. I'm very much thankful. Okay, sir. Good morning to all. I'm very much thankful to Professor Ramanathan sir, who is a good friend of mine for a long time. And it was an accidental meet with him, with his friend who is a classmate here, Professor Venkatagalam, of Pharmacy Department of Annamalai University. Being introduced, fruitfully we are carrying out for the past 15 to 16 years, continuously even after retirement. Now let me come to the subject. I also thankful to all the participants for having here. Since this is a keynote address, it is not possible for me to go into the details of a single area in which we have to speak. But what I can do the best is, I will give a small, very small introduction as a tip of an iceberg for research metrics, writing a project proposal, how fruitfully we can do, and what are the research communications on different papers in pharmacology, pharmacy, and also medicine, biomedicine, chemistry, and so on and so forth. Let me start first with the research metrics. Actually, it's a quantitative analysis of scientific and scholarly research outputs. What is an output? What you are finding in the research and how you are going to show it to the public or even to the research counterparts in the whole world, and how do you measure the impact out of that? Research metrics include variety of measures. That's a statistical method recently being developed around 2005 for assessing the quality and broader impact of scientific and good quantifying research, as well as to track the difference between the apples and oranges. Research metrics measures impact and provide insight into the influence of specific journal publications, individual articles, and authors. What are the varieties in that? We have journal metrics. We call it as impact factor, you know very well. The growing research scholars happen to know about the impact factor. Whether the impact factor given by the journal is right or wrong, there are so many queries in that, and we can see that slowly. Impact factor helps to track citation patterns within journals and determine which journal are highly cited, and which we can find whether the journal is a quality journal or not. Author metrics measures the impact and productivity of a researcher, quantifying him or her. Article metrics or citation tracking is used to determine an article, book, journal, or particular author has been cited by another work. That is so called as an article metrics. It is citation tracking of an individual or even an article published by a single author. Article, even a book, journal, or particular author has been cited by another work. Alt metrics. Alternate, that's the meaning, help researchers to measure the impact from papers, datasets, websites, blog posts, and more. These research metrics can be used, that's a very important thing, for us, a faculty who is working in different areas, maybe from history or from immunology, whatsoever the case, or even in pharmacology, pharmacognosy, and chemistry, organic, whatsoever the case, to support applications for grant funding, to support applications for their promotion, by a researcher to maintain their own research profile, in department and faculty reviews and national assessment and accreditation exercises. What are the issues to consider in that? Citation counts can be affected by a number of other ways. No single source is comprehensive. Publication dates may affect your results. So if you go deep into that, you can study slowly. Don't worry about what I'm saying now. These are all the points to be considered. Frequency of a journal may affect our results. Highly cited article is a very important point. Yeah, highly cited articles don't always mean an excellent research. That is something which is called as an esteem, must be taken into account. For example, a journal which is published in mathematics is not equivalent to a journal which is published in history or even chemistry or pharmacology. because the subjects are entirely different, and the maximum impact factor of a very good Mathematica journal is just 1.8. But if you go into the scientific journals, the maximum impact factor goes around 54 of a journal. So it is not the journal that the impact factor of a journal or even the person who is publishing is the matter. The subject is actually coming into account. Research measures across disciplines. What I'm saying now, research measures across disciplines may differ. So here there is no point of comparison. Next, let's see what is citation data. It is generated by counting numbers of times publications have been cited. You publish a paper in the European Journal of Medicinal Chemistry. How many times is cited by how many authors in different journals? Allows for the analysis of relationship between publications. Measure of importance and uses. Another name for the field is called as bibliometrics. We call it, librarians used to say, bibliometrics. First proposed by Egan Garfield in 1955, Garfield founded ISI. The ISI is nothing but the Institute of Scientific Information. Through ISI only, we have several citation data, analytical measures, and also different search engines in computer science. What is the citation index? The citation indexing makes links between books and articles that were written in the past and articles that make reference to cite these older publications. We need one simple example is in American Chemical Society journal recently I published a 10th standard boy from United States. I published an article written to the editor stating that how safely we can keep sodium. So he just given a letter to the editor. That letter to the editor is published and that cited more than 1,000 times. In other words, it's a technique that allows us to trace the use of an idea, an earlier document, where we can go into it and find the lacunae in it and get that problem into our account and get depth of it and find some results. Those results could be easily published. That is called as citation. So each and every innovation or research or even a discovery, whatsoever the case, there will be a benchmark paper. What's the benchmark paper? In the particular area, which is the first paper published, is called the benchmark paper. For example, the benchmark paper for Albert Einstein is EZ is equal to mc squared. That's the benchmark paper. That is the origin of theory of relativity in his case. There are three kinds of citation data. Articles, called citation impact. For authors, it is called as H index and I10, and that can be extended to I20, so on. Journal impact factor for journals. So there are three kinds of citation data: citation impact for articles, and authors, H index, H, and I10 index, I20, etc. Journals, journal impact factor is the measure. So let us go into it. Journal impact factor, how that is calculated. One demonstration I have given, one hypothetical example. For 2-year period, citing references appearing in 210 to articles published in a journal in 2009 and 2008 is 100. Citing references. Total number of articles in the journal published in the 2 years is 200. So divide 100 by 200. That is actually the journal impact factor. So references appearing 210 to articles published previous 2 years, and the number of articles published, total number of articles published in the previous 2 years, you have to divide, and that is so called as journal impact factor. So what, now see the definition: number of citations to a journal, number of citations to a journal by different authors in different fields It may be science, engineering, technology, or even history, whatsoever the case, given in from articles occurring in past 2 years in a journal, divided by the number of scholarly articles published in the journal in the past 2 years. That is so-called as journal impact factor. Now let's come to H index. So what's a H index? An index that quantifies both the actual scientific productivity and the apparent scientific impact of a scientist. Okay. A scientist has a H index if H of his or number of papers, MP is number of papers published over n years. It may be 20 years, it may be 10 years, it may be 5 years, or it may be 3 years from the start of his research career. At least H citations each. How many citations those papers had? Other NP minus H papers have no more than H citation each. A scholar with the index of H index of 40 means that scholar has published 40 papers each, of which has been cited by others at least 40 times. If one is having a H index of 20 or 27 means, as indicated, a scholar with an index of 40 means H index 40. A scientist who is having H index of 6 is enough to consider as a good scientist. 6 and more than 6 are superfluous. A scholar with an H index of 40 means that scholar has published 40 papers, each of which has been cited by others at least 40 times. Okay, that is called as a H index. What's an I-10 index? I-10 index refers to the number of papers with 10 or more citations. A single paper of you published in 2019, cited within this period of more than 10 times by different authors in different fields of science, then that is called as I-10 paper. I-10 is one this. It was introduced in July 2011 by Google as part of their work on Google Scholar. It is their contribution, a search engine dedicated to academic and related papers. If you look into a demo of Albert Einstein Institute of Advanced Studies, Princeton Physics, no verified email at the time, title 1 to 10, in a paper called Can Quantum Mechanical Description of Physical Reality Be Considered Complete? Albert Einstein, his students Podolsky and Rosen. Physical Review 47-10-777. You see there, cited H index overall citations is having 95,822 since 2010. Even after his death, science never been forgotten, ever been remembered. This kind of research work, 32,085. So overall H index is 108. Since 2010 is 867. As time goes on, Albert Einstein's theory would have been a change in that, and people whatsoever the case will want to cite the first benchmark paper and related to that, so that H index will remain not less than 10 at least. So that is there. His I-10 index is 366 overall, and since 2010 to 19. That is what is there. The year of citation is 14,019, year of publication is 1935. So 65 plus 22, 75, 85, 87 years till now, he is having a H index of 67 from 2010, overall of 108. What's a good G index? Recently, new metrics has been introduced that is so-called as a G index of 20 means that the academic has published at least 20 articles that combined have received at least 400 citations. So if you published in your overall journey from the start of your PhD or from your M.Pharm till the end of your DSc, if you have publication of 20 articles, good articles, but combined to receive at least 400 citations, then that is called as G index of 20. You can calculate accordingly how many citations you are having. Suppose if you are having 2000 citations out of 100 papers, you can calculate it. However, unlike the H index, these citations could be generated only by small number of articles. Okay. That is a recent one. So we have to see Web of Science, the use and abuse of citation data. Web of Science, previously known as Web of Knowledge, is a database for bibliographic citations. I told you what is bibliographic. Of multidisciplinary areas that covers the various journals of medical, scientific, and social sciences, including humanities. Okay, that is to know about the citations. A Web of Science is developed. Okay, Web of Science is one. Scopus, next one is Scopus. Now, if you go into some of the PhD submission requirements of different universities in India, different universities are having different scales. Some of the controller of examinations are asking us to go for Web of Science publications in which is cited at least 2 papers, and some other universities are concentrating on Scopus. Scopus is Elsevier. It is a publisher. Elsevier's abstract and citation database. It is actually launched in 2004. If you are a researcher in 1988 like us, like me, so Scopus will not be there to help us to show that he is a good scientist, or even it may say he is not at all a scientist. Okay. Scopus covers nearly 39,647 titles. From approximately 11,678 publishers, subject fields of life sciences, social sciences, physical sciences, and health sciences. So most of the universities are now concentrating on Scopus. Publisher, Royal Society of Chemistry, American Chemical Society, and Frontiers, and others. If you go into that, the overall publishing, 10% of the total publishing scientific journals comes with Elsewhere, 8%, and 5% Wiley Blackwell, and Tyler and Francis 5%, Sage, Waters, likewise, Oxford, Cambridge, Bentham and Science, IEEE, but Royal Society of Chemistry, American Chemical Society, Frontiers occupies nearly 60, and others. Scopus publication for subject area. So life sciences 17%, social sciences 31%, around 31, and physical sciences around 27%, health sciences 26%. So social sciences takes a higher one. Social sciences 8,690, health sciences 7,133 journals, physical sciences 7,441 journals, life sciences 4,601 journals. Neuroscience, inclusive pharmacology, biology comes under that. Physical sciences, chemistry, physics, and engineering. Health sciences, 100% medicine, nursing, and dentistry. Social sciences, psychology, economics, and business, and all. Sources of citation data. ISI, I told you, Web of Science. Journal citation reports. ISI, Web of Science, Google Scholar, and Emerging Source Citation Index. Other products, Scopus, are available. The uses of citation data by researchers. To look for researcher which updates earlier findings. Okay, this is very important. Identify more articles on same topic. To look for replication of empirical research. To follow a scholarly database through time. To identify significant publications. Historians examining scholarly trends developed in the area, starting from Mohenjo-daro and now ending with now what we are doing at Ramnath. Okay, Kiraka. The uses of citation data for administrative purposes, tenure and promotion, funding and applying for grants in different granting institutes, deciding where to publish, So that's very important thing. First, if you know that your work is a standard work, so we have to test with a very high impact journal in that area. And they will give you proper suggestions, including the editor. And they may also direct it to go for this journal rather than ours. And we can go for it. So that is the decision, deciding where to publish. Libraries used to make collection decisions. In the demonstrations, journal citation reports, Web of Science, Google Scholar, and we have to know the research scholar who is joining recently or for a long time should know the term publish or perish. Publish or perish is an alternative of force describing pressure to publish academic work in order to succeed in an academic career. Okay. Thinking critically about citation analysis, not necessarily. So all articles are not the same. Okay. Disciplinary cultures are there. It is not possible to compare history with immunology. So there's a difference between apples and oranges. Next, manipulation of rankings. So you can manipulate your ranking. You can increase on your own H index. You can do self-citation. Journals publish more review articles even for a month, 2 months, 3 months, 6 months, and bi-yearly, tri-yearly, quarterly, etc. Some journals encourage citation from same journal. Speeding up publication cycle increases impact factor. So the impact factor is not a very good criteria, but you know the esteem of your work. What is an esteem? It's a quality, truthfulness of your work. That is the one which is needed now, not the impact published in 5.4. The impact factor is being generated. The impact factor for recent journals will naturally be less than 0.1. But if you look into the websites, you can see certain journals that have been started recently having an impact factor of more than 5.4. You will astonish to know what is happening. Okay. Science Hub obtains papers through use of usernames, passwords supplied by people who receive them legitimately or from the black market of stolen university credentials. Okay, that is so-called Science Hub. And these are all the things that we must be very careful. Pirated softwares use or reproduce another's work for profit without permission, usually in contravention of a patent or copyrights. You know about that? We will come to that a little later. Plagiarism. So is the wrongful appropriation and stealing and publication of another author's language, thoughts, ideas, or expressions, and the representation of them as one's own original work. Plagiarism is considered academic dishonesty and a breach of journalistic ethics. You know about ethics. No credit is given stealing and published material. Small modification made. You know, when we have studied around 9th standard or 10th standard, there is in English 2 paper, we used to have paraphrasing. So paraphrasing is nothing but a part of plagiarism. If you just think twice, you can understand what I'm saying. Intellectual property rights, IPRs. Intellectual property rights are legal rights that are perfect protects creations and/or inventions resulting from intellectual activity in the industrial, scientific, literary, or artistic fields. The most common IPR include patents, copyrights, marks, and trade secrets. We used to say trademark. You have the trademark from each and every producer. You know, for Goodyear, a tire manufacturer, entirely different from Atlas. So you are seeing every day in your roads different cars. Every one car is having its own trademark. Copyright. So plant breeder's right. Next one. Utility model. Design. Design is also one IPR. Geographical indication. Trade secrets. So all coming under intellectual property rights. What's copyright? What can you legally photocopy for personal use? Actually, if you are going for a Xerox center, you should not give any book to completely Xerox. That's actually the copyright violation. You can copy a fair amount of your own private study, research or critical review. Photocopying is restricted to whichever is greater off. Up to 5% of one chapter of a book or one article from a single issue journal. That's all. Up to 5% of one paper of one set of conference proceedings, not all. Up to 5% of an anthology of one short story or one poem, not poetry. Poetry, it's a collection of poems is called as a poetry of not more than 10 pages. Look at the point. Up to 5% or one case of one report of judicial proceedings. The Matthew effect. The rich get richer and the poor get poorer. A centrifugal effect is there. High journals rankings are self-perpetuating. Okay. You know about centrifuge. So the denser will come down and the less denser will go up. Hard for new journals to break into high rankings. I told you just now. It is not possible for a journal which has been recently started should have an impact factor of more than 5. Anglo-American bias is there. Non-English language citations undercounted. So there is a journal called Angwandi Chem, which is the best journal in chemistry and pharmacology. But how many of us are knowing it, I don't know. But if you publish the impact factor of that now is 16, that is the only journal in regular physics or chemistry or even biology which is having an impact factor of 16. Highest impact factor journal in basic sciences is that. But how many of us are knowing? Because that is being published in German. An English version is also available. Non-English language citations, Russian journals, even Ukrainian journals. We are not aware of it. In those cases, it is not being counted at all. In those cases, the effects are very, very less. We can't see that. Next, I told you just now, I just completed metrics. Okay. There are several things which has to be told, but I told you it is a keynote address. I have to show only the tip of an iceberg in that area. Next, how to start a research in our area. So we started our research along with Ramanathan. Professor Ramanathan is only introduced, I'm a pure organic chemist. And he told me initially in 2007 after getting a DST project, and I have sent to one of my students there, he told these are all the molecules needed for my project. And can we synthesize in our laboratory? I told it's okay, sir. One of my students has been sent there. I have given all the fundamental ideas and also the protocols and the schemes for the preparation of the compounds which he indicated. The student stayed with him. He provided generously his guest house provision and also food, and stayed there and synthesized more than 30 compounds. That is our first door opening. Okay. Well, I had been introduced by him what is chemoinformatics. Now I could very proudly say that because of him, I'm a good chemoinformatic person now in this area. Gathering systematic use of chemical information and application of this information to predict the behavior of unknown compounds in silico. In silico means system. In your system, you need not go to a lab. If you are knowing the compound structure, get the compound structure as a data to your system, and your system will predict whether the compound can be used as anti-malarial or antipyretic and so on. That is what is called as the basics of chemoinformatics. The second part of the chemoinformatics, which is entirely different, wherein one of my students called Shankar, P. Shankar, who is the head of department of engineering chemistry at Pondicherry Central University. And he is doing that, he is developing programs for making easily how the compound structure can be easily framed over any system, any computer, even our laptop in 3D. That is the second part of chemoinformatics. Okay. In our case, as an introductory measure, I want to say a drug candidate is called as a ligand. Actually, for an organic chemist, a ligand is a small molecule which is surrounded by a metal ion where it can go and bind with anything. But here, a ligand is a small organic molecule, or it may be a protein or an enzyme. Okay. It has to go to a target. The target is actually a larger organic molecule, which is a protein or an enzyme. But a ligand is a very small molecule like crocin, which is nothing but para-acetaminophen. So take ligand is a para-acetaminophen, and where it goes and binds hypothalamus that contains certain enzymatic reactions, where it is called as a protein or a target. And in this way, they initiate a process. The initiation of a process of attaching a ligand over the receptor is called as an agonistic approach. And if it inhibits it, and then it is called as an antagonist. Very simple thing in this chemoinformatics. The structure, conformation of a ligand is a complementary to the space defined by the protein is called as an active site. Here, even if it's a small molecule whose molecular mass is not more than 150, and if it is having certain points where it can go and attach with a protein or an enzyme on its own site, those sites are called as active site. The binding is caused by favorable interactions. The interactions are plenty, bonded, non-bonded interactions between the ligand and the side chains of the amino acids in active sites. Those interactions are called as electrostatic or hydrogen bonding, hydrophobic, hydrophilic, or even other things also there. Those are called as London dispersive forces in presence of water molecule and in absence too. So in a drug discovery process, we have in vitro, in silico studies. So we have to go first for in silico studies. You know the disease, you know the biological target where it is being attached, and you can find a drug candidate. And we can go for animal studies, then go for clinical studies. Finally, that comes as a drug. Know that. So it's a long process, more than 25 years. Genomics. Next, bioinformatics, gene and protein. Structural bioinformatics, high throughput structure. Hit molecule to form. Chemoinformatics. Then we have to find the lead. For example, lead. Best lead antibiotic accidentally found is penicillin. That's called as a lead. After finding of the penicillin by penicillin, you know very well, penicillin has been further improved and expedited over several antibiotics of the same kind. Okay. When Alexander Fleming first found that as a penicillin is one of the lead, from the penicillin, he found several penicillin, beta-lactam antibiotics. You know that. Structure-based drug design. Next one is now what we are doing is ADMET, absorption, distribution, metabolism, excretion, and toxicity modeling. So in a drug discovery process, we know the structure of the biological target. If you know, okay, we identify, predict the binding packet. Okay. If you are not knowing it, you know the ligand structure. From the ligand structure, you can find and predict the binding packet and challenge, design an organic molecule that would bind strong enough to biological target and moderate its activity. New drug candidate is formed. So, you know that. In this area, there are several universities which are giving, University of Indiana giving bioinformatics courses for 3 months, 6 months, and 1 year. University of Sheffield, University of Manchester, John Hopkins University School of Medicine, and molecular interaction, etc. here. In this field of top journals, Journal of Chemical Information, that's for pharmacy, pharmacology, and also even for immunology, chemistry, organic chemistry, physical, inorganic chemistry. Journal of Cheminformatics, Journal of Computer-Aided Molecular Design, Journal of Molecular Graphics and Modeling. This second part I told you. Journal in the field called Journal of Chemical Theory and Computation, that comes in the second part. Journal of Computational Chemistry. Most influential, prestigious journals we have to consider as biologists, particularly Nature having an impact factor of 42.79, New England Journal of Medicine 74.7, Science having an impact factor of 41.84, IEEE 45.17, Lancet, which is a medical journal, having a 59.1, and Cell having 38.64, and Nature Communication 40.62. Angman Chem, you look into 15. I told you now, it's a German journal. 15.34, one of the best journals which gives only the true ideas in chemistry and biology. Chemical Society reviews, nucleic acid research, etc. So we divide this into this particular subject of information and presentation into bioinformatics and chemoinformatics. Bioinformatics deals with gene and proteins, and cheminformatics drugs, lead and drugs. So bioinformatics lets large molecules, whereas the cheminformatics leads small molecules. The combination of these two gives rise to a fine drug. So in chemical information system, you can find any information by typing the user name in SciFinder. Go to the site. Any paper you can get it. User name. You can go and it's a free one, SciFinder. PubChem. Now let's come to the next area. I feel it is very, very pertinent for all of us. How to write a project proposal fruitfully and get it. First, we have to go. I will show a small demo in which we have written a project recently for this BSR fellow. Also, I have written a project and got it. Now, after retirement, I am working with that. And Ramanathan sir and myself has written more than 5 projects. All of are combined together. I have written the chemistry part of it, and he has given the biology part of it. And finally, it is being built up and interlocated. That is synergic effect. The synergic effect made us to get all the projects. First, you have to define the problem vividly and present your solution. Next one, the same one. Define your deliverables and how long you will get a success in that. State your plan or approach. Outline your schedule and budget. As Sir told in his introductory remark, and we have to, someone will explain about how to give the UC, utilization certificate, and progress report, etc. That's fine one. We scientists concentrate on doing the work, and we are not commerce personality, and hence we are failing in some cases. We spend more in a particular heading, which is not scheduled to us. Now we learned after getting more than 4 or 5 projects. This is the limit, this is the limit, this is the limit. Within the limit we are doing, and after that we are actually sending back the money. Tie out all together, edit, proofread your proposal. So, tips for writing and compiling project proposal. It's a success story. Cost, budget, estimated delivery. Very important. If the project cost should be logical. If it, you know very well 60 lakhs is enough. We should not write for 1 crore. And proposition is important. And give the solution to that. Problem statement is very important. National level and international level, what are all the papers being published. And before writing the project, we should not write as a blank space. Instead, you have to start at least 6 to 7 months or 8 months of previous study. Or already you have published a particular paper. That paper will tell you these things where we can write a project, where we are lagging, and that can be certainly given by funding. So these things are taken into your account, and you have to write the project proposal. Steps to write a project proposal. First, where to concentrate. Executive summary. Briefly explain what to come. That is the first thing. That is summary. You should not start with introduction. Explain project background. Present your problem in detail. Present a solution. Outline how we will reach a solution. Define deliverables and goals. Identify what items you will deliver to the funding agency. List required resources. Calculate your project for equipments, for manpower, for chemicals, and also special chemicals, and travel, and other things. State conclusion. Confidently restate your case. So we are given green synthesis and development of thiazolidine-dione derivatives as one example I am citing now, as neuroprotective molecules through inhibition of neuroinflammatory markers. Theme-based called a proposal initiated by Program Advisory Committee of Organic Chemistry, EMR. So I submitted that. So we are given first the project title, scheme, broad area, chemical sciences, duration, everything is there. So you have to go into it very carefully. You have to address all these things. Project summary. Look at it. Heterocyclic compounds, analogous and derivatives have attracted wide attention. The aim of the current project is to develop thiazolidine-dione derivatives and identification of the target for the effective binding of thiazolidine-diones through molecular modeling, COX or GSK3 beta, and evaluate their efficacy in controlling neuroinflammatory Parkinson type, actually, using in vivo and in vitro models. Pharmaco-required thiazolidine-dione for the selected target binding will be identified using GLIDE from Schrödinger and strike programs from Schrödinger. New chemical entities will be designed. Using chemical library and the ligands will appropriate binding energy showing good interactions. That is your pre-work in which you have already ascertained this area, we can go into it. And we have done the cheminformatics work in using the in silico model. After that, you are finding that if you go for an organic chemistry and produce and prepare certain molecules in that effectively, that will be a suitable deliverable. We have to find out. We have to say that. Prepared for the study will be GSK3 beta or TAX will be selected for the synthesis. Synthesized compounds will be evaluated for the enzyme inhibitory activity through screening and in vivo by middle cerebral artery occluded models. The conformations required for the enzyme. You know the difference between conformation and configuration. Configuration is the capital D or L or small d or L, but conformation is infinite. So even a drug which is being consumed as a crocin went into your system that is having its own conformation, that particular conformation has to go into the receptor site and bind it, then only it will act as an antipyretic, otherwise it won't. So conformation is entirely different between configuration. Configuration plays a vital role, no doubt about it, whether that is S isomer or E isomer. That is different. You know all these things in your pharmacology studies, but conformation is important. Enzyme inhibition will be validated for the study of the conformation and also the dynamic conformations. The Schrödinger software is the only software available. It is actually being introduced by our friend Ramanathan sir. Later, we got it in our own project. A copy of that has been given to me. And we learned for the past 2007, 15 to 16 years. So I don't want to say more than in that, but we are expertising in that. Still we are learning that. And enzyme inhibition will be validated using known enzymatic high throughput screening techniques. Okay, the mechanism of action like that. You have to write the project summary in this manner. Next, objective. Structure-based design and development of effective chemical using thiazolidine-diones and related heterocyclic scaffolds. Scaffolds is nothing but molecules. Using Schrödinger software, chemical synthesis of the best fit molecule and understanding the target selection. Evaluate the neuroprotective activity of the new chemical entities through enzymatic assay, elucidation of biological activity of the chemical molecule in vitro animal models. So likewise, keywords. Technical details, I told you, introduction, origin of the proposal, definition of the problem, Work done, review of status of research and development in the subject, national level and international level. I told you next one, references, recent references and important benchmark papers and valid ones. Importance of proposed project in context of current status, review of expertise available with proposed investigating group, institution in the subject of the project, it is collaborative, work plan methodology, time schedule of activities giving milestones, 6 months, 3 months, 1 year, 2 year, 3 year, like that, budget details and curriculum vitae of the project investigators. Now the funding agencies are plenty. We have to knock continuously. One point of time certainly we will get, and the quality. There are several things. I need not introduce all these things. You know that MHRD, Shell recently, and in the Tamil Nadu State Council also there, and SERB, and you have Council of Scientific Industrial Research, DBT. We are very much successful, sir and myself are very much successful DBT and DST. And I too had CSIR and UGC, ICMR also, MOFPI, that is a BRNS, Basic Research in Nuclear Sciences, like that. Even you can write for BRNS. How to get the published in top journals? Okay. Are you ready to publish? It's an outdated work. Incorrect conclusions, duplication of published work, not ready. Work has no scientific interest. If you have original results or methods, significant enhancement of published work, up-to-date review of your subject or field ready. Work advances the field. That is a very important thing. So we should not go in the trodden path where others would have been traveled and walked for a long time. So you have to find your own path. Even that has come from a trodden path, your path is entirely different to one deviating one. What makes a strong manuscript? A clear, useful, exciting message, even from the start, presented and constructed in a logical manner, allowing readers to easily grasp. So like a flow of a perennial water source. Editors, reviewers, and readers all want to receive well-presented manuscripts. Significance, that is the significance. What article type should I choose? Full article, substantial, complete, or comprehensive pieces of research. Is my message sufficient for full article? You have to think on your own with your collaborator. Letters or short communication, quick and early communications. Are my results so thrilling that they should be shown as soon as possible, like Sir C.V. Raman? Review papers, summaries of recent developments on specific topic, often submitted by invitation. How do I choose a right journal? Aim to reach the intended audience for your work. You know that. You are in pharmacology, pharmacognosy, or pharmaceutical chemistry, so on. Choose only one journal as simultaneous submissions are prohibited. Okay. Choose only one journal. Simultaneous submissions are prohibited. Supervisor and colleagues can provide good suggestions. Shortlist a handful of candidate journals. Investigate your journal list, aims, scope, types of article considered, readership, academic versus practice, subscription versus open access, speed of publication, peer review process, single blind, double blind, open, bibliometrics, and content innovation. Structuring your articles. So how to structure your article? Title, abstract, keywords first, search and find, then go for results and discussion. You know the methods. Excuse me. You know the methods, and then after results and discussion, you have to go for introduction. Finally, conclusions, acknowledgements, references, and supporting materials. Provide context. So that's the way in which you have to for the structures. The process of writing, building the article. Figures and tables your data, methods, results, discussion, conclusion, introduction, title, abstract, keywords. The process of writing, building the article from bottom up, figures, tables, that's first, methods, results, discussions, conclusion, introduction, title, abstract, and keywords. Covering letter. Your chance to speak directly to the editor, very important. Explain the main findings and motivation. Highlight novelty and significance of results. Don't simply say that I'm here in sending one of my manuscripts to your esteemed journal. That's not the right thing. Your chance of speaking directly to the editor. Explain the main findings and motivation. Highlight novelty and significance of results. State final approval of all co-authors. State prior reviews, revisions, etc. Note any special requirement suggested reference. State any conflicts of interest. Okay. What actually happens? Start, author, submit a paper. Okay. Revise. Basic requirements met. Yes. Assign, they will assign the reviewers. Collect reviewers and recommendations. Review given for recommendation. Make a decision. Maybe reject or accept. If it is accept, green, accepted. If it is revision, rejection means no problem. We can rewrite. Revision required, revise the paper. Again submit. It will follow the same way. Plagiarism in practice. Any of the following can be plagiarized. Words, ideas, diagrams, figures and tables, computer programs, findings, writings, information, lectures, presentations, printed materials, electronic materials. So these things you have to be very careful. Copying the word for a word, paraphrasing, already I told you. So there are programs are now available. A paper which has been published around 2018, if you want to have the same para converted into your own language of English, and there are paraphrasing softwares, you give the same paragraph that will give you in a different sentence. That you can incorporate. That is not the right one. For finding that also no software is available, that is turn it in. Plagiarism is easily detected but also easily avoided. I have to cross check, powered by indicate. There's a plagiarism checker. You can use ideas, phrases, arguments from sources already published. Just acknowledge the source and original author and include any directly copied text within the quotation marks with thanks. That is more than enough. So I have to show some successful stories of us. Okay. With Professor Ramanathan and my students and his students are in medicinal chemistry. Recent discoveries and developments of androgen receptor-based therapy for prostate cancer. From 2015, we started our research around 2007. The best publication we got from 2015. We worked very strenuously for nearly 6 years, okay, 7 to 8 years. After that, we start publishing medicinal chemistry research, 2016, and anti-cancer agents in medicinal chemistry. Anti-cancer in medicinal chemistry, 2017 also. Chemical-biological interaction, 2017. On breast cancer, we concentrated on breast cancer research and also mutated prostate cancer recently. For that only we awarded very good projects, very excellent projects from DBT, thrice, and one in DST, ICMR, and also 2 CSA and 2 UGC. So current computer-aided drug design and chem biodiversity in 2020 recently for anti-breast breast cancer and also for prostate cancer, our area we restricted anti-cancer agents in medicinal chemistry 2018, New Journal of Chemistry in 2015. These are all coming under that for breast cancer. Future Medical Chemistry 2018. The first one which we have shown is for prostate cancer. Now what I'm just showing is for 2018. We never look back into the journal which is not known to anyone. and whose impact factor is less and whose quality we know is not good. And we just not only for very good journals. Likewise, recently also this year, now also we publish a paper in Journal of Molecular Structure along with him. And with Ramanan sir, we got very good projects. Funding is a lot of funding. We got it from CSIR, DST, UGC, DBT, and DBT, NAC, Northeastern Collaborative Research. And we happened, by God's grace, happened to found certain best collaborators from Shillong and also from Assam, IASST, which is a centralized laboratory for DST, only one lab available for DST. And funding agencies, sincere thanks to UGC, CSIR, DBT, and DST, Northeast training programs. And our collaborators are Jaivan Koteki, Tanu Butler, and Professor Ramanathan, Principal Ramanathan, DSC, Principal, PhD College of Pharmacy, PhD Medical Center, Coimbatore, who is a best friend of mine. We actually extended and extrapolated our own friendship out of research. We did a comfortable research, excellent with friendship, and still we are friends only because only one thing exists between us, that is so-called the fire to go for research and the truth in it. And Dr. Raghu is always helpful, even if we are losing. I'm not having now the license for Schrodinger. Whenever I'm approaching him, of course, Sar is having no problem. But whenever I'm approaching him, he will give 1 week or 10 days. Once upon a time, for learning, it takes 3 months, 6 months, 8 months. Now within a week, we can do all these things. I am highly thankful to our sir, Ramanan sir, not because he's a good friend of mine, that is a different one, but very good researcher, really interested in research, and we did out of the truthfulness. I used to say at the end any of my lectures, an innovation, actual example for innovation, wherein I am sitting, I am just sitting the abode of Lord Nataraja in this, which is the center of the universe as a swastik point. This has been built around 2nd century, wherein there is no Michael Faraday, who has found that what is called as an electrolysis, electroplating, and electrographing, etc. But the coated one are excellent, and there is not even a small thumbnail which is showing an ugly face. So this is actually an innovation. That innovation should be in our research. Biodiversity, wherein I am here, it is surrounded by an excellent fauna and flora, where it gives enormous quantity of different birds in different areas, which is nothing but called as a Picharu forest, which is a mangrove one. These are all floating roots. This takes the water which is surrounded is more than 60% of saline, but the water which goes to the apex of each and every leaf is 0% of saline. So it is having a natural filter. That filter never equal to any filter which is given by us, which is called as RO plants. So the same area where I used to go, this from my place, this is just 39 kilometers. This is nothing but Gangaikonda Solapuram, whose architectural marvel has been recognized by UNESCO. If you happen to come over here, you can look into 20-kilometer stretch of Viranam Lake, as well as this place, which is an excellent temple. With this, my special thank to Professor M. Ramanathan, DSA Principal Sir, authorities of PhD College of Pharmacy, UGC for BSR Faculty Fellowship given to me after retirement, which is a prestigious one. I don't want to say again and again, but I am highly thankful to Ramanathan Sir, not only because having given me a chance to speak before you, but actually to share what we have done till date. We understood the subject. I'm a chemist. I'm not a pharmacologist, but he made me to learn pharmacology. And he has, first of all, in the first meeting itself, given me a book called Chemoinformatics. He told me to go into it as a student. I went into it sincerely. After that, I learned the Schrodinger and other things, and with a smart, good work for the past 15 years. So I thank the audience for your kindness. Any clarification I can acknowledge. Thank you. Sir.
Thank you, Dr. S. Kabilan, sir, for such an informative session. Now, the session is open for queries. Participants, delegates, if you have any queries, please share.
So, so Rajshekharan have mentioned it's a very nice presentation.
Thank you, sir.
Thanks it also.
Sir, all because you trained, sir.
No, sir, no, sir. Please, 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 sir. Sir, you are excellent chemist, sir. I have to, because I want to say something to the audience. See, I'm not praising. See, when we did our B Farm, that time pharmacy, we don't have any building. So we used to go to the chemistry department. So when we did our B Farm second and third year, like, when we go for organic chemistry and medicinal chemistry, sir used to work as a PhD scholar in the department. So we used to say that this is the place where the benzene Hercule rules have been followed. So many research has been done. So it's a beautiful place. Apart from this, I want to also share with the audiences. See, Sarah told so many success stories. There is also some difficult times also we have faced it. Some of our, not many, few of our projects also not got accepted. And we also learned through that why it has not been accepted, what could be the possible mistakes, and why the certain compounds are not answering well, what could be the new approach which can make it out. So this is the way how we learned it and we fine-tune it. So that is one of the take-home message for the members also, which I want to say. So we also have some failures. It's not that everything is success in the research. So that one should accept it. And that is my point, sir.
Yeah, true, sir. True.
So any questions, youngsters? Participants, any questions you want to ask? So one question, sir, why our functional chemistry people could not be a successful synthetic chemist in your experience, sir?
Sir, pardon. Sir, repeat, sir. Repeat, sir.
Sir, so our students also study chemistry, pharmaceutical chemistry. But my feel is why we are not able to be a good synthetic person. What is additionally required to be a synthetic chemist?
No, sir, you are totally, I feel, humbly, I feel that your area is having different theoretical subjects and are not supported mostly by mathematics. But in our general chemistry, we have basically a mathematics, physical chemistry, and organic and inorganic chemistry. Even in chemistry students, the persons who are really interested in organic chemistry is capable of shining and surviving, because the laboratory practice is entirely different. Every week, organic chemistry synthetic laboratory here for 3 full days. That may be one of the reasons. That may be.
Okay, sir. Okay. So, madam, do you want to have any questions to sir? You do a lot of synthesis.
No, sir.
Okay.
So I hope that I have given some touched surface only, because it is a keynote address. If it's a specific one, we can get depth of it. Thank you, whatsoever the case, you have given me a chance to me in keynote address, and I did to my satisfaction. I don't know about the participants.
No, it is really good, sir. It's really good. They could understand about the publication aspects, how to choose a journal, how to approach for any research work, and what are the basic things required when you want to apply for research projects, what significance of collaborations. So you touched upon all the aspects, sir. So that is, I think that is the way how the keynote address will be. And most of the students will are the faculty. So let them go in detail every aspect. Like even the like impact factor, many people may not know what is how to calculate impact factor, H index, then choosing the journal for their publications. So in those aspects, I think now we are given an overview of it. So it might definitely will help them, sir.
Thank you.
That is, sharing your experience is really a good one, sir. That's not no doubt on it.
Thank you.
Okay. So if there is no questions, I will ask the MC to conclude the session.
Okay, sir.
So anything, so any question they can type and I can answer, sir, in a later.
Okay, sir.
No problem.
Yeah. Definitely we'll mail you, sir. Yeah, definitely we'll mail you.
Okay. So once again, I thank you, Dr. Kabilan, sir, for your valuable words. Now let us wind up today's session now. We shall rejoin for the afternoon session at 2 p.m. You can join using the same Zoom link. Thank you all delegates and speakers. Thank you all for your cooperation.
Thank you, sir. No, leave on. Leave on.